Today we're going to talk about main boiler control, and that is a controller that activates your boiler. So how it works is you turn your thermostat on. When you turn your thermostat on heat, it sends 24 volts to a box. And the old type was a relay with a switch. So when it got to 24 volts, that switch would close. And that's what gave power to the circulators and to the burners. But this is an overview of what a boiler main control. The evolution of the boiler main operating control transitioned from simple mechanical pressure gauges and manual adjustments in early boilers to sophisticated electronic systems with advanced algorithms allowing for precise pressure and temperature regulation, often integrated with predictive maintenance capabilities, all while prioritizing safety and efficiency improvements throughout its development. The key stages in the evolution: early mechanical controls, pressure gauges and safety valves, the first basic control mechanism relying on visual monitoring of pressure and manual intervention to adjust fuel input based on pressure readings. Thermostatic controls, and that's the ones that I'm going to talk about today. Thermostatic controls, bimetallic strip-based temperature sensors to roughly regulate boiler temperature, often require manual adjustments. Pneumatic controls, mid-20th century. Air pressure-based signaling unit, then you got air pressure-based signaling, utilizing compressed air to transmit control signals between pressure sensors, dampers, and fuel valves, enabling more precise control than purely mechanical systems. Electronic controls, late 20th century. Microprocessor-based systems. Introduction of dedicated electronic controllers with improved accuracy and ability to monitor multiple parameters like pressure, temperature, water level, and fuel flow simultaneously. PID, proportional integrated derivative control loops, algorithms that precisely adjust fuel input based on deviation from set point, leading to more stable operation and improved efficiency. Modern digital controls. Present day. Distributed Control Systems, DCS. Network systems integrating boiler controls with other plant equipment, enabling centralizing and monitoring and optimization across the entire system. Advanced analytics and predictive maintenance, utilizing data from sensors to predict potential issues, optimize performance, and minimize downtime. Adaptive control algorithms, learning and adjusting based on operating conditions to further enhance the efficiency and responsiveness to changing load demands. Important factors driving this evolution. Energy efficient requirements. The need to minimize fuel consumption and optimizing boiler operations to meet environmental standards. Reliability and safety concerns. Development of advanced safety features to prevent boiler malfunctions and protect personnel. Technological advances. Continuous improvements in sensor technology, microprocessor capabilities, and communication protocols, enabling more sophisticated control systems. But now there are two. And these are mainly used in residential and some commercial. Like if you watch Steve Lab, they have a regular boiler. You have a mechanical an electronic main controller. So like I said, when you turn your heat on, your thermostat sends 24 volts to the main operating control. When it receives that 24 volts, it kicks that control in, and it sends power to the boiler burner and to the circulators. Now, the modern controls you have, these are set by temperature. The controls have a sensor, has a sensor probe that goes in a tube into the boiler. So it senses the temperature. A cold start boiler is just a cold start boiler, but they still have an operating control to run. So when it gets a cold start boiler, it may be 100 degrees inside the boiler. So when you kick that, when that control kicks in, it brings it up to 180, which is the high limit. And like, let me try to explain this. So there are boilers that maintain the temperature in the boiler. The high limit might be set at 180 or 190, but the low limit is set at 160. So if the temperature gets to 160, it kicks that boiler on and heats it up to 180 or 190. When it reaches that pressure or that temperature, it shuts off. And it's the way that the boiler maintains heat in the system. So we have come a long way, because we had mechanical ones and now we have electronic ones. And some of the electronic ones actually have a low water cutoff, which means when the water gets low in the boiler, it cuts off the control. The control shuts off as a safety. I'm glad I could help you with this. Thank you for watching.